Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list published on July 3rd, 2025. So, just yesterday. This paper introduces a new method for 3D scene reconstruction that more than doubles the semantic accuracy of previous models. The paper is titled LangScene-X. Reconstruct generalizable 3D language-embedded scenes with TriMap Video Diffusion, and it tackles the really difficult problem of understanding a scene from just a couple of images. The authors propose a new framework that generates a complete 3D scene, which also understands language, from very sparse views. Also, the authors shared their implementation on GitHub. And for anyone wanting to dive in, you'll find the full source code, setup instructions, and the necessary model checkpoints. They've included quick start scripts to help you get up and running with your own 3D scene reconstructions pretty quickly. On Hugging Face, you'll find links to the LangScene-X code repository and project page, though model weights and direct usage examples aren't available on the page itself. Alright, so this first figure gives a great visual overview of the whole process. On the left and right, you see the inputs. Just a couple of images from two different scenes, a kitchen and a tea time scene. The model then uses a TriMap Video Diffusion process to generate a consistent 3D view. And to understand language, it uses something called a language quantized compressor, which is a clever way to efficiently embed language information. The result, shown at the bottom, is that you can query the scene with text, like stuffed bear, and it highlights exactly where that object is. Building on that overview, this next diagram shows the language quantized compressor, or LQC, in more detail. This is the component that handles the language understanding. It takes in rich language features from an image and uses vector quantization, which is a clever way to compress that complex information into a much simpler, more manageable code. The language quantized compressor then uses this efficient code to reconstruct the scene and, importantly, to create a mask identifying specific objects when you query it with text, like cabinet. This efficient compression is key to making the whole system generalizable. So this figure really lays out the entire pipeline, showing how all the pieces fit together. On the left, it starts with just two views of a scene. These images are fed into the TriMap Video Diffusion model, which then generates a whole sequence of consistent predictions. These predictions include standard images, but also normal maps, which describe the 3D surface orientation, and segmentation maps, which identify different objects. Finally, using the language quantized compressor, the system reconstructs the final 3D scene, letting you generate new views and even ask where the bear is. Okay, so now we get to the results. This table shows a quantitative comparison on the LER-FOVS dataset. It measures performance using two key metrics: open vocabulary localization accuracy, which tests how well the model finds objects from text, and mean intersection over union, which scores how accurately the model outlines an object's shape. And the results are really impressive. LangScene-X, in the final column, dramatically outperforms all previous methods, more than doubling the mean intersection over union score from about 23% to over 50%. A huge improvement. Moving from the numbers to the visuals, this next figure shows a side-by-side comparison on the ScanNet dataset. We're looking at 2D segmentation masks, which are essentially pixel-perfect outlines of objects generated from text prompts like night table or storage cabinet. And when you compare the hours column for LangScene-X against the other methods, the difference is stark. The masks are much cleaner and more comprehensive. In fact, they often have sharper boundaries than the other methods, and in some cases, are even more complete than the ground truth data itself. Alright, to understand why LangScene-X performs so well, this table presents an ablation study. That's where you systematically remove parts of the model to see how performance changes. The rows show the model with different components removed, like the progressive training, the language quantized compressor, and two different loss functions, which are scoring rules that guide the learning. And the results are clear. Removing any single component hurts the segmentation accuracy. But when all the pieces are working together, as you see in the bottom row, the model achieves the highest scores. So as that ablation study really highlighted, Every component is critical for top performance. To wrap up, LangScene-X presents a really promising new direction. It succeeds at building these generalizable, language-aware 3D scenes from just a handful of images, which is a major leap over older methods. The two big ideas are the TriMap Video Diffusion model, which cleverly generates consistent color, geometry, and object information, and the language quantized compressor, which efficiently encodes language without needing per-scene retraining. Together, they create more accurate and versatile 3D worlds. That's all for this AI Research Roundup. Thanks for tuning in.